Well, pre-calculus classes, good morning, good afternoon, or good evening. As always, we will go ahead and finish up section 3.4 here. I know in the last set of notes we were looking at solving exponential equations. The last half of this section is solving logarithmic equations. So we'll go ahead and get started into that. And again, just, certainly as you work through things on Pearson, just kind of watch what the directions are on your rounding. So, to start out, natural log of x equals 5. Well, anytime you are solving with a logarithm with a variable inside of it, the only option is to change this into exponential form. So what we'll do again, just certainly keeping in mind, well, for natural log, the base is e. So this one's relatively simple, but we'll take our base e to the 5th equals x. And so now just go ahead and enter that in, and it's, around 148.413. All right, so now this next one goes back to the one-to-one properties where you have log base 3 of 5x minus 1 equals log base 3 of x plus 7. It's different than example A, and that example A only has one logarithm. If you only have a single logarithm, you definitely will have to change it into exponential form. Well, here, if you have a logarithm on each side, this is where we can use the fact that, well, as long as they're the same base, you can set what's inside each logarithm equal to each other. If they were different bases, you would not be able to do much with that problem at all. So, for this one, 5x minus 1 equals x plus 7, and then from there, subtract the x and add the 1. So 4x equals 8, and x equals 2. So, again, that's a little different style than A. C is actually a lot like A, other than the fact that you do have some extra steps with this one. So, now we do have some values outside of the logarithm to worry about first. So subtract, 2 natural log of x equals -1. Then we will divide, and then, so now we have natural log x equals -1/2. Now we're back to what we had up here in example A. So our base is e to the -1/2 equals x. And it's 0.607. So again, for the most part, these probably a little quicker than some of the things we were doing yesterday. Although when we get to the next page, there will be maybe a little bit more involved problems. But for D, really the only difference from either A or C is now you just have a different base, but we'll still go ahead, divide first. I mean, I suppose you could move that in as a power. I wouldn't. I would go ahead and move that over first. I think that's your easiest option. So log base 5 of 3x equals 2. Now again, the only way to get rid of a logarithm is to change it into exponential form. So 5 to the 2nd equals 3x, and then from here, x equals 5 squared is 25 over 3. There I would just leave it as a fraction. Again, you can certainly say it's 8.3 repeating if you want, but I would just stop there at that point. So that is example 1, those 4 different ones. Now, the one thing that you do have to be careful about is logarithms are another type of problem that can have extraneous solutions. I know we've seen that with rationals where you have variables in the denominator. We've seen that with absolute values. If you have an absolute value problem where there was a variable outside of the absolute value, We also saw it with square roots, radicals. Again, if you especially had a variable outside of your radical, that can occur. If you have multiple logarithms to start a problem out, it is possible you could get an extraneous solution. I mean, even back to this one, if I plug the 2 back in there, 10 minus 1 is 9, 2 plus 7 is 9. You just have to make sure that what's inside your logarithm remains positive when you solve it. So, especially the ones where you have to condense, that's where it's very likely to occur. So again, I know I kind of already alluded to what we're going to need to do, but log 5x plus log x minus 1 equals 2. Well, in order to condense, we are going to have to multiply and distribute. So 5x squared minus 5x equals 2. Now, from here, again, we have a logarithm that we need to get rid of. When you don't have a base written in, base is 10. So 10 squared will equal 5x squared minus 5x. And I'm just going to go ahead and move the 100 over. 10 squared is 100. Now, again, I know I've talked about this. Going to divide everything by 5, since I see that will definitely make this problem easier for us. So now, when we factor, it's what multiplies to negative 20 and adds to negative 1. With 4 and 5, we need negative 5. So our factors, x minus 5, x plus 4, kind of out of room, so x equals 5 and negative 4. Now again, here's where what we have to do. Plug these back in and see, do we end up with a negative inside a logarithm? Well, if I plug the 5 in, that's 25. That's 4. So the 5 works. If I plug the negative 4 in, I have the log of negative 20. I also have the log of negative 5 there. So this one is the extraneous solution. So our only answer is x equals 5. So that again is one of the additional places where you do have to worry about an extraneous solution. So for the final example here, deposit $600 at 5.25% interest, compounded continuously. How long will it take to double? Well, again, right now, keyword here, compounded continuously. Now, another important word is, yes, how long will it take to double? But the key is continuously. When you see that, it means we do need the PERT formula. So, from here, the 600, that is the principal. E is E, the rate 0.0525. And then since we're looking for how long, T is our variable. Now, the reason why I said yes, how long will it take to double is another keyword. Well, our $600 is doubling, so that puts 1,200 over there. Now, you're just solving an exponential equation. So this is kind of like what we did the first half. So divide by 600. 1,200 divided by 600 is 2. E to the 0.0525 t. And again, just a reminder, I don't know if I actually said this, but just remember, with your percent, move the decimal. And now, to get rid of e, we're going to use natural log, which, not that you really have to show this, I just like showing that. That allows you to move the exponent from e out to the front. And now we can divide. So natural log 2, again, do watch, close your parentheses before you divide. and it's going to be a little over 13 years. And again, it is a word problem, so go ahead and put that appropriate label there with your answer. So again, 3.4 we looked at really two different topics, solving exponential and logarithmic equations, but that does finish up 3.4, and to be honest, really finishes most all of the new material for chapter 3.